we're going to go through some more examples on how to graph these quadratic functions by hand, and first give it a try on your own to list out all the information, and whenever you're ready you can continue the video and we'll go through all the steps. Alright, so let's look at part A first, and the first thing I'm going to do is just to kind of list out all the information I need and go from here first. Alright, to start, for x of symmetry, we're going to use x equals negative b over 2a as a formula for finding the x of symmetry and x-coordinate of the vertex. And therefore we would get negative b, which is 1, over 2a, which would be 2 times negative 1. As a result, we would get positive 1 over 2 as the x of symmetry. And that should also give us x-coordinate of vertex. So to find the y-coordinate, we're looking for f of 1/2, which would be negative of 1/2 squared plus 1/2 plus 6. And if we calculate it, we get negative 1 over 4 plus 1 over 2. If you want, you can convert 1 over 2 to have a common denominator of 4, which would be 2 over 4. Plus, similarly, 6 would become 24 over 4. And therefore, if we calculate everything, negative 1 plus 2 would be positive 1, positive 1 plus 24 would be 25. So we get 25 over 4 being the y-coordinate of the vertex. So therefore, I know I need the point for vertex being 1/2, 25 over 4. And we can highlight it. So for y-intercept to be 0, it's a constant. You can find it's a mirror for the x of symmetry. What the x with the that we just found in its mirror image over here to work. The only way we can solve this case, I already wrote down the form. In, we would b, which is negative 1 times 2 times negative. Simplify this. Just cancel each other out. It's plus minus 5. X is equal to over negative 2 will be positive 3. And I'm going to highlight that for our that are relative to work with, and I'm going to use 2 for example. And we don't want to repeat points, so I'm not going to pick 1 or 3 for example. And here if I have f of 2, we can calculate it to be negative 2 squared plus 2 plus 6, which is equal to negative 4 plus 2, which is negative 2 plus 6 will be 4. And therefore, if we want to find its mirror point, we can think about a similar way. If, say, 2, 4 was over here, to go equal distance on the other side, say over here, we have this distance being 1.5 or 3/2. And if I want to go to the left, subtract 3/2 of symmetry. So 1/2 minus 3/2 gives me negative 2/2 or negative 1. And therefore, this is the other point that I want to have. And these are the 2 points I want to include in this process. 2, 4 and negative 1, 4. And now with all the information we get, we can go ahead and start graphing things over here. And here I'm going to scale the axes first. You can see we get pretty large y values overall, so I'm going to just use each box as 1, and I would have 2, 4, 6 over here being the y values, and we can see really don't hit any negative y values directly with our points, but we can still label it really quickly. And then for the x-axis, we would have the points that are just going anywhere from positive 3 to negative 1, I believe. So with that, we can use every 2 boxes being 1 over here. So I'd have 1, 2, etc. So that would be 4. Same thing on the other side. And now if we want to put all the points in, I'm going to take a minute to plot these points. The first one is 1/2 and 25 over 4. If you notice, 25 over 4 is just over 6. It's 6 1/4, 6 1/4 over here. So we want to go for the height of 6 1/4 with the x-coordinate being 1/2. That's a vertex. That's probably the trickiest to graph among all the other points. And here I'm going to take a second to plot all the points first. Points all plotted, so I'm going to just connect them and get this somewhat smooth curve of a parabola that's opening downward, and that's my graph for f of x in this case. And that's how we graph part A. Whenever we're ready, we can move on to part B of graphing over here. Now in part B, we start with the same thing. For the x of symmetry, negative b over 2a should be the x-coordinate and x value for our equation. So we get negative of negative 4 over 2 times 3, which becomes positive 4 over 6, or 2 over 3. And therefore, to find the vertex, we want to find g of 2/3. And to get g of 2/3, we would have 3 times 2/3 squared minus 4 times 2/3 and minus 2. Altogether, if we want to simplify things, we get 3 times 4/9, which one of the 3's cancel each other out. And this becomes 3 times 4/9, or 4/3 overall as a result. Minus 4 times 2/3 would be 8/3. Minus 2, again, it's a good thing to convert 2 to 6/3. Altogether, we should get negative 10/3. So I know my vertex is going to be 2/3, negative 10/3. That's the first key point we get. And now for y-intercept, we would want to find g of 0, which is equal to negative 2, or 0, negative 2 as a result. And for its mirror point, because we know the y-coordinate should be the same, and the x-coordinate should really just be double the x-coordinate for the vertex, or for the axis of symmetry. So we get the mirror point is 4/3, comma, negative 2 as a result. And these are some things that you might get more familiar with as you practice more for finding the mirror point without trying to graph anything anymore. And for x-intercept, we are going to go ahead and plug things in. Negative b is negative of negative 4 plus minus square root of negative 4 squared minus 4 times a, which is 3, times c, which is negative 2. And this is all over 2a, which is 2 times 3. And altogether, we get 4 plus minus. Under the square root, we would get 16 plus the product here, because we have two negative signs. So you get 16 plus 24, which will be square root of 40. It's all over 6. And as a result, we can simplify the radical a little bit and work with that. So square root of 40 over here is really equal to square root of 4 times square root of 10, which is equal to 2 root 10. So if I want to write it out, it'll be 4 plus minus 2 root 10 all over 6. And here we see every single term has a factor of 2, so I'm going to go ahead and just reduce the fractions here to be 2 plus minus root 10 all over 3. And this is another place where we have radicals, so we probably want to use a calculator to find out exactly where these values are, or at least have a good estimate as to where to plot things over here. And I'm going to use a plus first, the 2 plus square root of 10 over 3. I'm going to use a parentheses because I need parentheses around the top of the fraction. So 2 plus root 10 all over 3. Make sure to close the parentheses first, divided by 3. And we get about 1.72 as a result. I think that's what we have, 1.72. So the first point is about 1.72 comma 0, because it's the x-intercept. Y is equal to 0. The second point should still have y-coordinate being 0, but the only thing I need to change is to change the plus on top to be a minus on top. That gives me negative 0.39 if we have to round up. And we can copy that, comma 0. And these are the x-intercepts. They're not particularly nice and even numbers, but we can still graph them nonetheless. And I'm going to go ahead and highlight the key points so far. And next we have more freedom of picking whatever number we want to work with next. I'm just going to use 1 over here for the next point. So for g of 1, this is equal to 3 times 1 squared minus 4 times 1 minus 2. As you get more familiar with this process, you can do the calculation faster as well. 3 minus 4 will be negative 1, minus 2 will be negative 3. And that tells me the first point I picked randomly was 1, negative 3, and now I want to find its mirror image, so I know the x of symmetry is x equals 2/3. Therefore, it shows me that 1, negative 3 is to its right, and to find its mirror image I want to go to the left for the same amount of distance, the distance here being 1/3. I want to go another third to the left. So 2/3 minus 1/3 gives me 1/3. Being the x-coordinate, same height, means y-coordinate is still negative 3. And the next part for me is to go ahead and scale things. And this is where I like to use the fact that all the denominators are 3. So with that information, I'm going to use every 3 boxes to be 1 for my x-axis. And I'm going to do the same for y-axis because I also see some y-coordinates being multiple or having a denominator of 3. And these are some nice things to take advantage of for having these fractions to make your graph a little bit more nicely. Similarly, we can do this for the negative parts. Alright, so this will be negative 1, negative 3. And the first point we want to graph is 2/3, negative 10/3. So 2/3 would be over here on the x-axis, and negative 10/3 would mean I want to keep going essentially to the 10th box down, because this is negative 3 and 1/3. And this is going to be the vertex. Then for y-intercept, we had 0, negative 2, so 0, negative 2 is exactly here. Then we have 4/3, negative 2. Again, I want to count to the 4th box on the x direction. So 4/3, negative 2. They are indeed equal distance away from the x of symmetry. Then I have 1.72, comma 0. So this is somewhere you kind of have to eyeball a little bit. So it's just past the 2/3 way between 1 and 2. Then negative 0.39 be somewhere here. And next we have 1, negative 3 and 1/3, negative 3. So 1, negative 3 is exactly here. 1/3, negative 3 will be right here. And now we can go ahead and connect the dots. And we would get the graph for g of x. And whenever you're ready, we can move on to the next question for graphing. For the next problem, we are doing essentially the same process and trying to find the vertex and axis of symmetry first. Get negative 2 over 2 times negative 1, which ends up being positive 1. And for vertex, using the x-coordinate being 1, we have h of 1, which will give us a y-coordinate. So we get negative 1 squared, which is 1, plus 2 times 1, so 2, minus 3. So as a result, we get positive 1 minus 3, or negative 2. So that tells me the vertex is going to be 1, comma, negative 2. Now for y-intercept, we want to find h of 0, which is negative 3. So 0, negative 3 would be the point I want. And using the y-intercept and the x of symmetry, I know the mirror point of y-intercept should have the same y-coordinate as the y-intercept, and in terms of x-intercept, it should be twice the value of the x-coordinate of a vertex or the axis of symmetry, because they're equal distance away from the axis. So I get 2, comma, negative 3 as a result. And the longest part, the x-intercept, if we plug things in, negative b is negative 2 plus minus square root of b squared, which is 2 squared, minus 4 times negative 1 times negative 3 all together. And this is all over 2a, so 2 times negative 1. And as a result, if we calculate it, we get negative 2 plus minus square root of here, we get 4, and we would have minus. Here we have 4 times 1 times 3, which is 12. And this is something we want to be careful with, because now if you look at the radical, I have square root of a negative number. And as a result, I'm not going to find any real number answers when I simplify this process. And what that means is that I can't really find any real number solution using the quadratic formula. And that tells me, as a result, there is indeed no x-intercept at all. That means my graph doesn't intersect with the axis. And therefore, I don't need to keep solving this anymore once I notice whatever is inside is less than 0. There's no real number answers for the x-intercept. So that means I can just go towards the last step, which is a random point of my choice. So for that random point, I'm going to choose h of 3, because I can't choose 1 or 2 anymore. They're going to give me redundant information as what I've already found. Actually, in fact, I'm going to choose h of -1, because that's the next easiest number we can work with. So if I have h of -1, I would get negative of -1 squared plus 2 times -1 and minus 3. So to simplify things, we would get -1 minus 2 minus 3, which would be -6. So I know -1, -6 is going to be the point I have. And I also know the axis of symmetry is x equals 1. So -1, -6 would be somewhere here. Let's say to find its mirror image, I want to use the fact that the distance between the two is 2 over here. So I want to go another 2 being the distance to the right. So 1 plus 2 gives me the x-coordinate being 3, and same height gives me the other point being 3, -6. And these are the other 2 points that we can use to graph. Again, if we count the number of points, we have 5 points, which is enough for us to start graphing. And looking at the values, I do have some fairly negative values, but otherwise I don't have very large range of values to include. I'm going to just go ahead and fit -6 over here, meaning every 2 boxes I go on the vertical direction, I'm going to consider that as 1. And I'm going to do the same with the x direction with the x-axis to scale things, just so I can have the same scale. And here we would get these values labeled. The first point we get is 1, -2. So 1, -2 will be over here. That's going to be the vertex. And we also notice there's no x-intercept. That's actually a quick way for us to see this graph is going to be opening downward. And then for y-intercept, we have 0, -3. And its mirror point will be 2, -3, right over here. Then we don't have x-intercept, so we can skip that part C. And for part D, we have -1, -6, which would be way down here. Lastly, we have 3, -6, which would be down here. Now connecting all the points, we can have this parabola graph for the function h of x. And all the steps we did in this problem is identical to what we did before. The only exception is when we had this case of no x-intercept, when we use a formula for a quadratic solution and find out that the radical part has a negative value under the radical. And that's how we work with this type of problem.